competitors, and welcome to lesson 102 on comparing mass and weight. So the difference is that mass is the amount of matter in an object. It has nothing to do with gravity, and so it's going to be the same no matter where you were to find the mass of yourself. So for example, we use a balance in order to find mass. So if I were to get on a balance and figure out that I weigh 60 kilograms here on Earth, then if I were to go to the moon or be in space and get on a balance there, it would still say that I am 60 kilograms because that's how much matter I make up, and that's not going to change no matter where I go. Whether I'm at the bottom of the ocean or the top of a mountain or in outer space, my amount of matter stays the same. Okay, mass is what is used for science, and we use the metric system to measure it with a triple beam balance. So here are some common things to kind of get an idea of how big they are. A milligram is 1/1000th of a gram. Okay, and that would be as small as like a grain of sand or salt. If you were to picture how much one little grain of salt or sand or sugar weighs, that's 1 milligram. Paper clips, one paper clip is about 1 gram. And then a math book is about 1 kilogram. So a math book weighs 1,000 times what a paper clip weighs, and a paper clip weighs 1,000 times what a grain of salt weighs. But even still, even though kilo means 1,000 and it's our biggest form of metric, the kilogram, it's still not super heavy. I mean, if I was weighing something like a spaceship or a cruise boat, it would be a lot of kilograms to measure it. And so it's important to realize that when we're comparing it to the US system of tons, that a ton is a lot bigger than a kilogram, even though those are both the biggest of their systems. All right, so an object's mass stays the same anywhere it goes. We already talked about that. And we're going to use a triple beam balance to measure when we're talking about grams and mass. How does that compare with weight? Well, weight is the amount of gravity on an object, okay? It's how much gravity is acting on the mass of the object. So what that means is if you are anywhere on Earth, you have about the same amount of gravity acting on you, so your weight will stay the same as you move around the Earth. But if you were to travel somewhere where there's a different amount of gravity, like in outer space, then your weight is going to change. It is not going to be the same. So in the US system, we measure weight in pounds and tons and ounces, and we're going to talk about that in a minute, but you have to know that that is different from measuring mass because there's the factor of gravity. So for example, if I was 100 pounds on Earth, okay, if I were to go to outer space and stand on a scale, which is what we use to measure weight, it's different from the balance that we use to measure mass. If I were to stand on a scale here and be 100 pounds and then go to the moon and stand on a scale, the moon has less gravity because the moon is smaller than Earth, so there's less gravity acting on it. So even though my mass is the same, I still take up the same amount of matter, the gravity acting on it is going to be different, and the number on the scale would be smaller. It might say that I only weigh like, I have no idea, but let's just guess that I would weigh like 50 pounds or maybe even less than that, maybe like 30 pounds, depending on how much gravity there is. In outer space, if you weren't attached to anything that had any gravity, if you were in a place with no gravity, then the scale would say that I weigh 0 pounds because there's no gravity pulling down on that matter or my mass. All right, so here we have the US customary system. So this is talking about weight. An envelope and a letter would be about 1 ounce. A shoe is about a pound, and a small car is about a ton. So notice that the pound is more similar to a kilogram, 16 ounces in 1 pound, and 2,000 pounds in 1 ton. All right, on Earth, a kilogram is about 2.2 pounds. So if we want to convert between kilograms and pounds, then we need to know this conversion. This is really important to me because I somehow messed up my scale at my house and it's set to kilograms now. So it keeps telling me my weight in kilograms and I have to convert it to pounds in order to figure out whether I've gained weight or lost weight or whatever. So it's kind of funny. I've been doing this all out in my head. 16 ounces is 1 pound, 2,000 pounds is 1 ton. All right, converting. So here we got 2 kilograms equals how many grams? We're going to follow the same steps I always tell us to. So we're going to start by writing what we know, 2 kilograms, put it over 1, multiply it by another fraction. The same label that's up here is going to go down here. What I want is going to go on the top. And now what's the relationship between grams and kilograms? There is 1,000 grams in 1 kilogram. That was on the other page if you didn't remember that. And now I look, can anything simplify? No, it can't. So I'm just going to multiply 2 kilograms times 1,000. The kilograms are going to cross off. 2 times 1,000 means that it is 2,000 grams. That easy. All right, here's B. 5.5 grams. Put it over 1 times another fraction. Write grams on the bottom so they'll cancel. Kilograms on the top. I do want you to show your work for this for both of these to get credit because we're learning the processes here. There are 1,000 grams in 1 kilogram. I look to see if anything will simplify. And then I'm going to multiply across. And I'll get 5.5 over 1,000. Which means that I need to divide this by 1,000. And remember, dividing by any multiple of 10 is as simple as moving the decimal place. So just so you can see it, I will rewrite it down here. So I'm going to make this number smaller by going to the left 1, 2, 3 times, which is the amount of zeros in 1,000. So my answer is 0.0055. So 5.5 grams is hardly any kilograms. Okay, C. Now in this problem, we're going to start by adding the ounces and then we're going to add the pounds. But since there's 16 ounces in a pound, if this number gets higher than 16, we're going to have to take out one of the whole pounds from it. So we've got 12 plus 6, which is 18. And then 7 plus 2, which is 9. But here I have an extra ounce. So I need to take one of these ounces out, which I'm going to do by subtracting 16 ounces, which is going to give me just 2 ounces left. And I'm going to add 1 pound because that's what the 16 ounces equaled. So then I get 10 pounds, 2 ounces. All right, what about for subtraction? Well, I'm going to start the same way. 10 minus 12, I can't do that. So that means I need to borrow a whole. It's kind of like borrowing a whole from a mixed number. I'm going to borrow a pound, and I'm going to make this just 8 pounds. And I'm going to take that pound and change it into ounces. So how many ounces are in a pound? 16. So that means I'm going to have to add 16 ounces to this 10. So 10 plus 16 would give me 26 ounces. And now I can subtract 26 minus 12 is going to be 14. And then 8 minus 7 is going to be 1. So I've got 1 pound and 14 ounces. To check that, I could count up. I could add this to this and make sure that I got that. All right, try E and F on your own. Bring them to class with you tomorrow. Go ahead and get to work.